5.2 polynomials, linear factors, and zeros. So this is going to be reviewing from chapter 4. So now we're going to have multiple zeros. So in chapter 4, we talked about zeros of a function. So it's the number that makes the equation 0, the number that would make the equation, so the answer, equal to 0. This is also the number that passes through the x-axis. So that's what zeros are, where they pass through the x-axis. So first, if we're going to write a polynomial in factored form, so this one just says write each polynomial in factored form. First thing when I'm looking at this is what do they have in common I can take out. So looking at this, they all have an x in common right here. So I can take out an x, leaving me with x squared minus 2x minus 15. Now I can continue factoring this. So this x still stays out front. Now I'm looking for numbers that multiply to get negative 15, that add together to get negative 2 because there's a 1 here. So when I'm looking at that, the factors of 15 are 1 and 15, or 3 and 5. Well, 3 and 5 will work. So if I have a 3 and I have a 5, but one of them has to be negative, I have to add together to get a negative 2. So I'm going to put my negative with my 5, my positive with my 3. You can always check, remember, this would give me my negative 5x, this gives me my 3x, and together they give me a negative 2x, so that checks out. So for this first problem, I'm just asking you to factor it. So I am done. This is my factored form. Pause the video and try to factor the second equation. I can take out an x of all three of these, and now again, I'm looking for numbers that multiply to get negative 12, add to get negative 4. I can always check my work. Whoops. Outside would give me 3x, inside gives me negative 4x, and when I add those together, that gives me my negative 1x. So that works. So this would be my final answer. So for this question, I'm not going to be super precise. I am going to be looking for some key things here. You can use your graphing calculator on this if you want to. First, I'm going to find the zeros of the function. So this is already factored for me. Just like how we had done in the past, we set these equal to 0 and we solve them. So these are the zeros of the function. These are where it crosses my x-axis. If I'm going to solve this, I have x equals negative 2, I have x equals 1, I have x equals 3. So at negative 2, I can plot a point here. At negative 2, at 1, I can plot a point. And at 3, I can plot a point. You can use your graphing calculator for this next part, but you do not have to. Now when I'm looking at this, I have my degree here. There's 3 zeros. That means my degree is 3. That means that's odd. Odd goes in the opposite direction. So it would look something like this. Opposite always starts down first and then goes up. I did not flip at all. So if I'm going to do this, I can just go woo, woo, woo. Now, one thing about this problem that people always get confused on, this answer right here would be perfectly acceptable. If you also had an answer that looked like this, I would say both of those are correct. I don't care about what's going on here as long as it's not passing through the x-axis another spot. I care that you have these 3 zeros. These are the only 3 spots you're crossing your x-axis, and that your end behavior is correct. I want you to try to pause the video and try to do B by yourself right now. Welcome. So again, my 3 zeros are at 0, 3, and negative 5. My end behavior is down, up. So when I'm doing this, I'm starting on the left-hand side. I start down because that my end behavior is. So I'm starting down, and then I have to make sure I go through each of my points. Now, that would be a completely acceptable answer, and so would this. This would also be an acceptable answer, as long as you only go through your x-axis at those 3 points. Now, some people like to be perfectionists. So if you wanted to, you could plot this into your y equals, and then you could graph it. So if you wanted to try to be a perfectionist, you would try to match up your graph like this. Notice how my actual graph should be a lot higher. My actual graph should go woo, way above there and go way down here and then go. Again, I'm not caring about my turning points for this graph. I care about your end behavior and your x-axis. So another thing that we can do with our zeros, we can actually figure out what our original polynomial function is. So if my zeros are at negative 1, 2, and 3, I first have to write my equation. So this is kind of like x is equal to -1. So if I'm going to write my equation that got me that, I have to first set this equal to 0. So if I do my step before that, I would add 1 over. So this is how we got x is equal to -1. So this is one of my equations. So I'm going to write x plus 1 over here. So if I have x is equal to 2, the step before that that gave me that 0, I would have x minus 2 is equal to 0. So this is my second equation. So x minus 2. And if I have x equals 3, the step before that would be x minus 3 is equal to 0. So my third equation would be x minus 3. Now, you don't have to show this work for each one. Some people can look at the 0 and are able to write the equation. If that's you, that's fine. But this is not my final answer. I actually have to write out the polynomial. This is in factored form. So what I'm going to do is I'm going to just focus on these two first, leaving this x minus 3 still right there. I'm not going to touch that yet. And I'm going to FOIL this out. Or if you prefer the box method, then use the box method. But I'm going to do my first. So that'd be x squared. Outside would be x times x minus 2 would be -2x. Inside 1x plus 1x. And my last would be -2. Oops, -2. So I can combine my two like terms in the middle. So I have x squared. This becomes minus 1x minus 2. Okay, that's these first two multiplied together. Now what I have to do is still multiply this by this. And because this is a trinomial, because there's 3 terms here, trinomial, I'm going to use the box method. And whenever there's more than 2 terms, I personally like using the box method to multiply. I have my x squared minus 1x minus 2, and I have x minus 3. So you always multiply to get in. So these two multiplied together would give me x to the third. These two multiplied together gives me -3x squared. These two multiplied together, -1x squared, because x times x is x squared. -1 times -3 is 3x. This would give me -2x, and this would give me a +6. Now, it's up to you if you prefer to rewrite all of these out. You can do that, or you can combine your like terms off of here to get your final answer. Typically, not always, but typically your diagonals are like terms. Or if you were to write it out, you would see that these two are like terms and these two are like terms. My final answer would be x cubed -3x squared minus 1x squared give me -4x squared. 3x minus 2x, 3x minus 2x would give me plus 1x. And then I have my +6. This right here is my final answer. I want you to try to do question C, actually no, D by yourself right now. Pause the video and do D by yourself. 2 or 3 equations should have been x minus 3 for this 0, x minus 3 for this 0, and x plus 3 for this last 0. If I multiply these two together, you should get x squared minus 6x plus 9. Then I multiply these together using my box method, and this right here is my final answer. Just to let you know, if you chose to multiply these two together first and got your answer, then multiply it by this, you should still get this as your answer. The order that you multiply these does not matter. Your final result should still be the same. Here we're talking about multiplicities. Multiplicities is how often a 0 occurs. So we only did A and D. So A, our zeros were at -1, 2, and 3. All of these have a multiplicity, I'm just going to write an M for that, of 1. They all occurred one time. In D, we had 3 and -3. Because this 0 happened 2 times, this has a multiplicity of 2. -3 happened 1 time, that's a multiplicity of 1. Now, when you look at a graph, it has a multiplicity of 2. It bounces off of that location. It goes, hits it, and turns around right away. And last but not least, we're only going to do this A, and then we're going to focus on the rest of these in class. So if I'm going to sketch a graph, the first thing I have to do is factor this and find the zeros. So I can take out an x squared out of all of those, and then I can look, okay, what multiplies to get 16 and adds together to get -8 would be x minus 4, x minus 4. One thing I see here is that my zeros would be at x is equal to 0. That has a multiplicity of 2. Here, if I set this equal to 0 and solve this, this would be x equals 4, and that has a multiplicity of 2. Now when I'm graphing this, there's two things I'm going to say focus on. This will give me my degree. When you add your multiplicities together, that gives me my degree. This is positive. So my leading coefficient is positive. So that means my degree is even. It's going to go up, up. When you have a multiplicity of 2 on your graph, it bounces, like I just said. So I'm going to put a star here. So at these two zeros, right here and at 4, 1, 2, 3, 4, I'm going to put a star at those two zeros because that means it bounces. So I'm going to start up because that's where my end behavior goes. I'm going to hit that star, bounce up, turn, bounce. Okay, I'm not touching the x-axis at any other points than those two right there. Again, you could plug this into your graphing calculator to look at what it should look like. This would be an acceptable answer for me as long as your end behavior is up, up, and it bounces on those two zeros. Does not go through, but bounces. Again, we're going to do the rest of these in class. You can try to do them if you so wish to. But other than that, have a great, grand, wonderful day.